All right, so this is Unit 11, Lesson 12, and we're going to cover organic acids and esters, two more organic compounds from Table R. Very common on the Regents exam are organic acids. They look similar to some of the other ones. In fact, organic acids look similar to the next one, which is called an ester. What helps you to differentiate is that this C double bond O, OH, is always at the end in an organic acid. So if you take a look at this example here, first thing is you notice COH. You name organic acids, it's relatively simple. It's based on the number of carbons, so this is based on methane. And you change the E at the end of methane to OIC, and just put the word then organic acid. So that's methanoic acid because it has one carbon and this O double bond H. Propanoic means that you have three carbons and the double bond O, and it doesn't matter whether you put the OH here or at an angle, it doesn't really matter. And these, of course, would have the bonds around it. That would be propanoic acid. They are just like regular acids, like arrhenius acids. They are electrolytes. The difference is that they're organic because they contain carbon, and the acids we talked about in the other unit didn't contain carbon. So these are organic acids. Those are inorganic acids. Next ones are esters, and you can see how they can confuse them with organic acids. If you look at the example that you see here, notice that it has similar to what the organic acid had, but it has the COO in the middle. These are the most difficult and confusing to name. So here's what you have to do. You locate the oxygen that's single bonded. The part that's attached to the oxygen is the branch. That's considered the branch. Okay, that's the branch. And the rest of it is the parent chain. So let's do the parent chain. It is based on propane because it's three carbons. And you change the ending from the E to the OATE. And then you name this branch. That's one carbon, it's a methyl. So this would simply be methyl propanoate. Okay? Now, following what we did here, this is the branch. This is the parent chain. So the parent chain here is simply just one carbon. That is here. You have this. It's attached to an oxygen. And this oxygen is attached to prop, which is three carbons. So it's 1, 2, 3. Let's make sure that every carbon has 4 bonds. That would have to have 2 more bonds. So this would be propyl. I'm sorry, this is an oxygen, so that wouldn't be 2 bonds. Sorry about that. So this is the oxygen. That's the branch. That's propyl. And methanoate comes from the fact that there's just one carbon in the parent chain. And those are esters. You know what? We're going to do amines and amides. Okay. Now, amines and amides are easy to determine, to differentiate between all the other ones, because amines and amides are the only ones that have nitrogen in it. So if you take a look at amines, obviously they end in the letters amine. Okay. So here's what you have to do. If you take a look at this one here, you can see that the amine group, the function group, is right here. And it's based on how many carbons you have. So it's 1, 2, 3, 4, 5. It's based on pentane. Change the ending to amine. Now you have to indicate where the amine group is attached to, and here it's attached to the second carbon. So it is attached here. So it's 2-pentanamine. Okay. Okay, so here we have the next one here. It's based on propane, so it's 3 carbons, 2, 3. And the amine is on the first carbon, so it's either here or here. So I'm just going to put it here, NH2. Put the rest of the bonds. And there you go. This you don't have to worry about. They're just going to give you the basics when it comes to amines. And let's do the next ones. Okay. I'm missing amides. Don't see it. Okay. So I guess we're not going to worry about it. Quickly, just run through it, and rarely do they give you this, but this is a compound that you probably learned about in living environment. Amino acids. An amino acid is sort of a combination of an amine functional group and an organic acid functional group. So that's where they get the amino acid from. You don't really have to worry about these. You notice that you see the COOH is what you'd see. I think you can see better here. Here's the COH that an organic acid would have. Here's the NH2 that an amine would have. That would be an example of an organic acid. Let me go back because he doesn't have amides in here. So let me go back to table R, quickly run through amides. I guess his feeling is that they don't give them very often. Okay. So if you look at this, you're going to notice that here's the amide. Notice that it has not only a nitrogen, but an oxygen. So it's the only one. It's probably the easiest one to identify. And again, it's based on how many carbons. So this one has 1, 2, 3 carbons, so it's based on propane, and you simply change the ending to amide. Again, they don't ask them a lot, so we're not going to worry too much about them. And that's the end of this unit, this lesson.